Very welcome to our HackerRank Tech Talk presented by the HackerRank campus crew here at Unisa. My name is Patience Mabuza and I'm your host today. I am the event coordinator at HackerRank Club Unisa, and I'm so excited to see all of you here. So today is about building skills that actually matter. Whether you are preparing for tech interviews, you want to level up your coding, or you are just curious about how algorithms work, you are in the right place. So let's get started. First, I would like to introduce you to the people who are making this happen. We are the HackerRank campus crew at Unisa, a group of students passionate about building a coding culture. So let me quickly introduce the team. We have Smangam Kunu, our president, myself, Patience Mabuza, the event coordinator, Snenhlanhla Ntsele, our treasurer, Mapaha, our public relations officer, Yuseria Ismail, who's our secretary, and a special thank you to our advisor, Dr. Kanyisa Dwabu, Acting Deputy Director at the Academy of Applied Technology and Innovation. We really appreciate your support. So yeah, guys, feel free to reach out to any of us if you ever need help. So what's the menu today? Here's what we will cover. First, Smanga will introduce us to algorithms and binary search. Don't worry if that sounds intimidating. He makes it super simple. Trust me on that one. Then we will have two of our volunteers, Charmaine and Musa, come up and solve some coding challenges live. This is the fun part. You will get to see the real problem solving in action. And Charmaine and Musa, I hope you guys are ready to share your screens when you solve the problems. And finally, we will have a very special guest speaker, Cynthia, who's a tech recruiter who helps students just like you break into the industry. Yeah, so let's dive in. Before we jump into the content, let's talk about why we are here. We designed this session to help you build a strong problem-solving skills, the kind where you actually get help in the interview. You get comfortable with coding challenges, learn practical strategies you can use right away, and hear from someone who actually knows what hiring managers are actually looking for. Whether you are a first year or nearly a graduate, there is always something here for you. All right, let's get into the good stuff. I'm going to hand over to Smangam Kunu, our president, who's going to walk us through algorithms and binary search. Smanga, you can take it away.
Good day, everyone. My name is Simanga. As patient has introduced me. Thank you for joining us. I'm going to go through our. I hope we can see our slide. Can you see my slide?
Yes, we can see it.
Thank you very much. Today we're gonna go through some about algorithms. Hi, Ratila.
Oratile, your hand was up.
Yeah.
Maybe it was by accident. Please continue.
Thank you, Chair. Okay, thanks. Today we're gonna go to talk about algorithms. The big word. I'm not sure should I go where does the word original come from? There was a guy called Mohammed Musa bin Al-Khawarizm. He's from Persian, which is currently Iran. He's the first one who derived the idea how to solve mathematics. He's one of the people who studied algebra. Or was one of the people who works on algebra in the early 80s, in the early 880. So today we're gonna work on what does then algorithm means in computer science. The system which is involved will power much of the technology we use every day, from the search engines and streaming apps to maps and navigation tools. Algorithm quietly make decisions that help us solve problems faster and more efficiently. So in this presentation, we'll explore what algorithms are, how they work, and why they are important in computer science. And then we're gonna go, what is an algorithm? So exactly what is an algorithm? So simply put, it is a step-by-step set of instructions used to solve a problem. You can think of it like a recipe. Just a recipe tells you how to cook a meal. An algorithm tells a computer exactly what step to follow to reach a solution. Just as a recipe has characteristics you need to use, so does the algorithm. Every algorithm has a few important characteristics. Its input process is through clear and definite steps, produces an output and eventually finishes. In other words, it must be precisely effective and it must stop after solving the problem. And then someone may ask, why algorithm? Algorithm matters because they make computer useful. Without algorithm, computer will not know how to search, sort, calculate, or make decisions. They help us save time, handle large amount of data, and automate complex tasks that will be impossible to do manually. Within an algorithm, we have something that we usually do, but we not necessarily know. We may not know what is searching. Maybe someone may not know, okay, but then what does algorithm do, and then why do we need to? In most cases, one common problem in computer is searching. Searching means finding a specific piece of information inside a collection of data. For example, finding a contact in your phone or locating a file on your computer. To do this efficiently, we use searching algorithm. And then we have two commonly used searching algorithm, which will be a linear search. Linear search items one by one, which is simple but slow for larger data. And then we have, which we're gonna go through today. I'm gonna try also to run through a linear in a few cents, but today we're more specifically gonna do the binary search. On the other hand, the binary search is much more faster, but it requires to sort the data first. Choosing the right algorithm can make a huge difference in performance. And then on the overview, what is binary search? Binary search is one of the most efficient searching techniques. Instead of checking every element, it repeatedly divided the data in half. This reduces the number of comparisons dramatically and make it very faster, and especially with a large data sets. In time complexity, the best case would be constant time, which is big O of 1. The weight case, which mostly we judge or we measure our computer on, it's big O of log. A big O of log n, which is divide and conquer. One may wonder then, how does the binary search works? On binary search works, first we look at the mix of the elements. If the value we want, we find it on a mix of the element, and then we're done. The algorithm stops. See, that's how it's fast. If not, then we eliminate the half of the list and then repeat the same process on the remaining half. This is what we call the divide and conquer approach and what makes it efficient. I'll go to the example of how the binary search works. We got the sorted array, which is 2, 4, 6, 8, 10, 12, 14. Our target, or what we're looking for, is 10. So the algorithm would go here is to go to the in a middle and then divide if we find to find 10. It asks if it's larger than, we see that the make is 8, and then we do, is it the target larger than 8 or less than 8? If it's larger than 8, and then we go to the right, and then we exclude, or we eliminate the whole left side. And then we go and search in the half. The half here will be between 10, 12, 14. The make will be 12, and then we will divide. We will look for the make. Okay, is it 12 larger than 10 or bigger? If it's 10 is less than, and then it means we eliminate the right side, and then we go to the left. Is it only 10 will be left? Here another example. We have 10, 15, 20, 25, 30. Our target is 15. So we walk through, we look at how many numbers do we have? 1, 2, 3, 6. And then we look in the monthly. Like here, we'll find on the first occasion, we'll find it on the first occasion, which is 15.
Rendani, do you have a question? Rendani, your hand is up. No, we can't hear you. Sorry, Smanga, I think Rendani has a question, but she's not audible.
Okay, can you hear me?
We can hear you perfectly.
Okay, maybe you can send on the chat.
Okay, she said she will send a text.
May I continue, or should we?
Please continue. We'll get back once she sends the text.
So here we have, okay, thank you, Chair. We have 1, 2, 3, 4, 5, 6, 7. We get 7 elements, or the 7 items, which is 2, 5, 10, 12, 15, 17, and 20. This is our item, which will be in computer, because computer start at 0, index 0, 1, 2, 3, 4, 5, 6. And then, okay, we have, let's say, binary. And then we have the list, which is already on the value. So here we will, because we will start initialize the say first. This is our HKC. Let it 0. And then from there, we need also initialize the last, which will be the length. This is list, length of list. But the last one, when we have a negative, is in this is a negative 1. The last item, negative 2. When you want to start from the back, negative 3, negative 4, negative 5, negative 6, negative 7. So we're giving the pointers, 2 pointers. The first one initial, which is 2, and then the last one, the length of the last one, which is 20. So when I use the while loop, I think while loop is linear. We're going to go to use a while loop. While first, which is that's 0, that's 2, the 0 index, while first is less than or equal to if list last plus with the length, and then we create a variable called Migli. And then creating an algorithm, you must add this first plus last, and then divide by 2. In Python, we're using double divide or double forward slash so that we can get an integer or one number. And then we ask if the value that we're looking for is equal to a list, the Migli list, the Migli number in the list, and then we say it must return true. And then elif, you need elif or if the value that you're looking for is less than or list of the Migli, the number of the number in the Migli. I see last. We're going toward the right. Migli. Or S. As the first. Then we're going to toward the left. Otherwise, if you can't find within these conditions, and then we return false. Excuse my handwriting. So this is a code, a pseudo code, if you may, but it generally just a code, like a real code, not even a pseudo code. So isn't we have 2? Was it 5? 5, 10, 12, 15, 19, and then 20. Let's say we're looking for 17. It's our target. So we're gonna go, we need to divide, we need to find the Migli here. Let's say 1, 2, 3, 4, 5. So our Migli weight is 12. So it's gonna ask, is this number equal to 12? You say no. Is it bigger than 12? Yes. So we cancel all this side. Now we are left 15, 17, and 20. We still, our target is still 70. So okay, is our number okay? We say 1, 2, 3. The Migli is 17. So is our number equal to the Migli? Yes. And then we find our number that we look for with search, and then we find out our target, which is 17. That's how fast is our binary search. So we divide and conquer. A simple a linear one will take time, because if you go, let's say, was it 5, 10, 12, 15, 17 and 20. With linear, we're gonna be looking for 15. So now, okay, 1. Is this equal to 7? Is this equal to 15? Is it equal to, we're looking for 17, right? Okay. Is this equal to 17? No. We go to the next one. Is it equal to 17? No. We go to the next one. Is this equal to 17? No. Is this equal to the next one? Is this equal to 17? No. Go to the next one. Is this equal to 17? No. Is this equal to 17? Yes. You see, the linear one, the linear algorithm will take time because we have to search it list by list, go by list. But when you go to binary one, we divide half of it and then you go to the. So if it's a larger item, means let's say there are 1 million items that you need to search. The item that you're looking for, it's at a 99,999. So we need to go forever. That will take time to do. It's a cost of the computer space. The graph of big O, linear is big O of n. So the more data we looking, the more inputs we're looking for, the more we spend time to looking for. And then the peak of log n, it goes like this. If it's small until when it's big, so roughly we find it here. Log of n, peak of log of n. The more the number big, the more we easily divide to find our target. We getting it done, and then okay, this is what I was talking about when I was saying we're looking for the condition if this number is bigger than this one or not. So in location, then that's why we make a decision. We use the if or if else statement, and then we loop through. If we can't find, then we terminate the process to prevent the infinity loop. Design algorithm. When we design an algorithm, where we break the big problem into small steps. We think carefully about the logic, the order, clarity before writing the code. Good design makes solution easier to understand, maintain, and improve. And then the complexity. Efficiency and complexity is very important in programming. Otherwise, we will be still using the 1980s computer, which will take time to solve. Efficiency is very important. We measure how fast an algorithm runs using the time complexity and how much memory uses with the space complexity. These are often described using the big O notation, which help us compare different approach. Remember when I say the linear will take more time because you have to loop through each element in order to find it, compared to binary where we have to divide each. We have to divide each half of the data that we have. And then we have other types of algorithm or techniques we use in an algorithm. Beyond searching, we have your main other algorithms like your sort algorithm where we organize the data. We're using on binary search where first we need to sort the algorithm. Let's say our data is not, because usually normal data or the real data usually they're not in ascending order or in sorted. So we need to sort. I think on Python we use sort a method. So there's a built-in method that you can use. Let's say we say num.sort, and then that way you use your method to sort. That is gonna sort your data. And then you have your recursion, which solve problem by breaking them into small pieces. I think the example you usually get in computer science is your factorial. It's your factorial, mathematical factorial, where you need to factor the number. Let's say n factorial, which is, let's say, is 5. So we need to break it down. Let's say in order to get what is the factorial of 5, which is 120. So we have 5 times 4 times 3 times 2 times 1. So each time then if you have to recursive, so each time a loop must go back. You times 5. You say 5 times n minus 1, which is 5 times 4. Go back n minus 1. 5 times 3, n minus 1, 5 times 2, until you find, until you reach which our edge case, or where a loop where it needs to terminate. It must not go beyond 0 because we get 0. So once it reach 1, you tell your algorithm to stop. And then you have your dynamic programming. Here it helps us to avoid the repetition or to repeat to work. And then you have your graph algorithm, which is one of the important algorithm in the world. It helps us to analyze your networks, your maps, or your social media connection. Advantage and limitation within the algorithm. Algorithm is very fast for large. This for data set, very fast for large data, efficient to compare with your linear. Limitation only works on certain data, which means you need to search your data before you search, work on a binary search. And then sorting may take extra memory. So it means you need to create a space for extra so that you can sort your data. Usually using your sorted, your built-in method is much more faster in programming. So because it auto do it for you. On conclusion, to conclude, algorithms are the foundation of computer science and modern technology. If you do not know algorithms, there is no way you can conquer the world of technology or computer science. One of the crazy stories that people usually ignore, the company Google, it was started because of an algorithm. They started a company based on algorithm. They call the rank page algorithm. So it ranks the things that you search on the net, and then it give you the better one. Rayleigh and Page, they started a company based on that one. So never say, hey, I'm going to jump because we have AI, I'm going to jump the algorithm, I'm going to jump the fundamentals of computer science just because I have an AI. You cannot solve any problem without knowing the foundation of the problem. In my closing case, binary search is powerful and efficient in algorithm when data is sorted. Understanding it built a strong foundation in computer science, which I think is very important. So by learning algorithm, we develop the logical thinking and strong analytic skills that are available in any tech field. Thank you for listening. I hand over to our patient.
Thank you so much, Smanga. That was super clear. I don't know about everyone else, but I'm already feeling like I can solve so many problems already. Anyways, does anyone have any questions regarding what Smanga just took us through? Any questions? Hmm. Okay, I guess it was clear. Okay, okay. Musa, please go ahead.
Hello everyone.
Hi.
Okay. Smanga, can you please go over the big O of both linear search and binary search for us, please?
The map. Let me the map, or what does it? Yes, the map, or what does it mean? The big O.
Sorry, come again.
You want me to go through again? How does it work, or what does the meaning of big O of n and big O of log
Oh
f
no,
n?
okay. I wanted to screenshot that graph. So
Oh,
yeah, thank you for that.
you could.
Okay, yeah, I'm done. Thank you.
Thanks, boss.
That's great. Anyone else who has a question or anything? I can see Rendani trying to talk, but we can't hear him. Rendani. Okay, guys, let's move forward. Musa, is your hand up again, or it's still that time? All right, thank you. Thank you so much, Smanga. Let's move forward. Ooh. Now for the interactive part, this is where you come in. Our two volunteers, Charmaine and Mosa, I hope you guys are ready. You have to come up and solve the challenges. Charmaine will have the diagonal difference problem and the staircase problem. Mosa will have the mini to max sum, the birthday cake, and time conversion problem. I hope you guys are ready. Are you guys ready? Mosa and Charmaine?
Yes, I am ready on my side.
Oh, great. We're going to start with you then, Mosa. I'm going to stop sharing and you can share your screen and solve the problem for us. You have 3 problems, right? Yeah, the stage is yours.
Thank you very much.
Sorry.
Okay.
Okay. For those who don't know, we have a WhatsApp group where we share these problems to all of you guys, and then you guys can volunteer to come here and solve them for all of us. We can all look at the process and help each other out. I'm going to post the link on the chat again, and you guys can join. And next time, maybe you'll be the one volunteering. Okay, Musa, the stage is yours. Thank you.
Thank you very much. Okay, let me share my screen. Okay. Okay, cool.
In the meantime, I see we have 2 hands up. Matlazi, please go ahead.
Hi, how are you? I'm Shirley. How are you doing that? So I told the person that with the presentation part, I'm going to explain how I got the solutions because already I've solved them. I'm the one who was sending one's views on the WhatsApp channel to show that I've completed all the challenges that I said I'm gonna do. So I'm going to like explain to everyone how I got the solution, not solve the question over again. I don't know if you guys understand me. That's what I said to that other lady. I don't know if it's a lady or but that's what I said. I said I'm just gonna share the code editor, show you and explain step by step how I got there, how I broke down the whole question for me to end up getting it correct.
That still makes perfect sense, Charmaine, and that still works. So we are okay with that as well. For now, let's just let Musa do his thing, and then after you can take us through it. It's okay. Musa,
Okay.
please, and I'm sorry
Thank
for the interruptions.
Oh no, no worries. I don't mind at all. Helps with easing my nerves. Okay, so hello everyone. My name is Musa Dondolo. I'm a 3rd year student at Unisa, doing Bachelor of Science in Mathematics and Computer Science. So the problems that I will be doing today is the minimax sum problem, as you can see here, and the counting maximum candles. So, and also the last one is going to be the time conversion problem. So going back to the minimax. So with the minimax sum problem, if I try to explain it simply using my own words, is that you are given a list or an array of numbers. In this instance, you will be given exactly 5 numbers inside that list. and then they will tell you that you need to find the difference between the sum of all numbers and the minimum, and then also find the difference between the sum of all the numbers and the maximum number, and then you return both those numbers. That's why it's called the minimax sum problem. You find the sum of all the numbers in the list or the array, and then you find the sum of 4 of the lowest numbers in that entire list, and then you find the difference between that number and the sum of the whole list. I will show what I'm talking about later when I enter into the code, and then on top of that, you find 4 of the largest numbers inside that list or inside that array, and then you subtract that answer from the sum of all numbers inside the list. So the aim of this is to find, okay, let me go to the last page, is to, the sum of all these problems is to develop the skill of pattern recognition in 5 things: in index navigation, and then in pattern construction, and then mathematical optimization, which is usually finding the most time complex solution to the problem, and then number 4, finding the right or the most optimum counting strategy, and also rule-based transformation. So going back to the first one, so I will start with the minimax sum, then I will move to the counting maximums, which is the counting of candles. And then the last one that I will do is the time conversion, which is converting from the American version of using the 0 o'clock to 12 o'clock, and then annotating it with whether it's AM or PM at the end, instead of the 24-hour time format that we use all around the world. So yeah, starting with this, the first one, I will go to HackerRank. So minimax, okay. Oh, let me change to light mode just so that everyone can see, because I'm a vampire. I prefer coding in dark mode, but for the purpose of this, I will use light mode. Okay, so let's read the problem. Given 5 integers, find the minimum and maximum values that can be calculated by summing exactly 4 of 5 integers. Then print the respective minimum and maximum values as a single line of 2 space separated long integers. So by that, they mean this. So it's 2 integers separated by a space. Now, like they said, you'll be given an array of 5 integers, like here, 1, 3, 5, 7, 9. And then what they mean by find the maximum and minimum values that can be calculated by summing exactly 4 of the 5 integers. What they mean by that is that we will go through each and every single member of this array, and then you will try to find 4 of the minimum values. So if you look at them, they're already in ascending order. So you can just take the first 4 items, which is 1, 3, 5, and 7. And then when you sum all of them, you get 16. And then the maximum, it's just taking all the numbers starting from the one in index 2 to the end of the list, which is 3, 5, 7, 9, and 24. And then when you print it, you just print the sum of those numbers. Now, they keep on giving you more scenarios. Function description: complete the minimax sum function with the following parameters. Array of 5. It's an array of 5 integers. And then print 2 space separated integer in one line. So this is basically repeating what we just read above. And then the constraint is that the the element inside that array cannot be less than 1, and it cannot be greater than 10 to the power of 9. So it will usually be somewhere in between here. But in our case, we have 1, 2, 3, 4, 5, or in the case above, we have 1, 3, 5, 7, and 9. So, okay, now let's go to the coding. So I will use Python, like Smanga just did above, because it's much more simpler for everyone to keep up with. Okay. Okay. Can everyone still hear me? Okay, let me check the other screen. Okay, yeah, I'm still connected. I thought I was disconnected for a second. So now, here we have a function, and then we are given an array called ARR. So let's remove this line and start writing code. So what we will do is first we will try to find the sum of all the numbers. So let's call it, sorry, we'll try to find the total of all numbers. So we'll just use the already pre-existing function called sum, which comes with Python, and then we'll just find the sum of the array. Okay. And then, okay, first I can try to just create total, but even if you don't create it, it's fine because it's already available inside the function. Then we'll next try to find the minimum sum of all the minimum sum of the numbers, all the 4 numbers. So minimum sum will now be equal to the total, sorry, minus the max. Now max already comes with with Python, so it finds the maximum number of. So now with this strategy that I'm using, since we have 5 numbers, for example, let me paste just so that we can see the list. So let's say array is equal to 1, 3, 5, 7, and 9. So since we have 5 numbers inside this list, in order for us to find the max of the 4 lowest numbers, here as we call it the minimum sum, in order for us to find the minimum of the 4 lowest numbers, we can just add all the numbers and subtract the largest number. What that will do is we will be remaining with the sum of these numbers, which is the minimum sum. So that's what I was trying to do here. So we subtract the maximum number of all these numbers so that we can only be left with 4 of the lowest numbers, the sum of 4 of the lowest numbers. And then we call that the minimum sum. And then let me just make it space. Let me make space so that it's much more clearer. Now we try to find the maximum sum. We do the same thing with it, but this time we subtract the minimum number. So we take the total again. Sorry, the total again. and then we subtract the minimum from it, the minimum of the array. Okay. So what this does is it tries to find 4 of the highest numbers inside the list and subtract the lowest one, which is 1. And then by that, we will be getting 4 of the maximum numbers. So let's try to print that and see what does it give us. So I know that's not what the solution wants, but let's just try to print all of these numbers that we have. So total, and let's print minimum sum, and last but not least, let's print the maximum sum. Okay, now let's run the code to see what do we get. Now this is what we get. So this is the total of all the numbers, which is 25. Ignore the error here. We're not solving the problem yet. We're just trying to see what do we get. So this is the total, 25, and then this is the minimum sum, which is 16, and then this is the maximum sum, which is 24. Now let's go back. For now, let me comment this out. And then actually, let me also comment this out because it's out of scope, but it's fine. And then now, trying to finally print the final solution. Let's print these two numbers, minimum and sum, but separated by space, like they had asked us. So print min, or we can print using an f string. So in Python, you can use an f string, which means you put the variables inside curly braces, and then everything else outside the curly braces will be taken as a literal string. So yeah. So yes. So as you can see, it's separated by space as they had asked us. And then inside the curly braces, I will just put in minimum sum. And then the second curly braces, I will put maximum sum. And then let's run that code. Okay. Expected 10, 14, my output. Okay. I think I misunderstood the problem. It expected, or maybe, just maybe, 4 of the lowest. Maybe this is what it wants. Instead of subtracting those, okay, let's see, maximum of the array, total. Oh, sorry, I'm passing in. So let me uncomment this line because it means I'm passing in my own array instead of the one that they will be using to test my function. So let me run the code one last time. So yeah, it passes if they use their own their own list instead of my own list that I had of 13575. Here they are using their own, and if we try to confirm if it is actually true, we can look at this. This is the input 1, 2, 3, 4, 5, and when we try to find 4 of the lowest, okay, let's first try to find the sum of all these numbers. So 1 plus 2, that's 3, 3 plus 3, that's 6, and then 6 plus 4, that's 10, 10 plus 5, that's 15. Now, 4 of the lowest numbers, the minimum number will be 1 plus 2, which is 3, 3 plus 3, which is 6, and then plus 4, that is 10. So as you can see, we have that 10 here. And then of the highest numbers, that will be 2 plus 3, which is 5, plus 4, which is 9, plus 5, that is 14. So we have 10 and 14. So yeah, we can submit the code. They will run it against their own test cases, and then it will tell you if they pass or not. So yeah, here in this case, they do pass. Any questions regarding this one before I move on to the next question? Oh yeah, I will assume there are no questions. So I will move on to the birthday cake solution. Let me go to the slides. So with the birthday cake solution, I will, okay, let me try to explain it reading from, okay, let me first explain it using my own words, and then I will explain it using what they have given us on their side. So what you're trying to do, they will give you a list of numbers, and then they will tell you that you need to find only the highest numbers and then return the count of those numbers. So sometimes you will find that the highest number repeats itself. For example, you have a list, maybe let's say of 1, 2, 3, 4, 5, 5, 5, 5, 5. So now 5 is the highest, but it keeps on repeating itself. So you need to return how many times does that highest number or maximum value return itself. So the way the scenario that they will give you is that there are candles, and then when you blow onto these candles, only the ones at the top will go out, the flame will go out. So you need to return the number of the candles that will go out. So that's basically the whole idea behind all of that. So let me go back to light mode again. Now I'm going to read it formally. You are in charge of the cake for a child's birthday. It will have one candle for each year of their total age. They will only be able to know, sorry, they will only be able to blow out the tallest candle of the tallest of the candles. Your task is to count how many candles are the tallest. Example, you have a variable, an array called candles. Inside that array, there's the numbers 4, 4, 1, 3. Now, if you look at all of these numbers, the maximum number is 4, and then it repeats itself twice. So that means only 2 candles will be blown out. So that means your function should return the number 2. And that's exactly what they say. The tallest candles are 4 units high. There are 2 candles with this height. So the function should return 2, as they said. And so yeah, here they just basically give you the parameters of the function. So the parameter is an integer, candles, which is n. So this is the candles heights. And then what you are returning is an integer, which is the number of candles that are tallest. So the constraints is that the number of candles should only be between 1 and 10 to the power of 5. And then the candles height themselves is going to be between 1 and 10 to the power of 7. So yeah, when you have this output here, for example, you have 4 items, and then those items are 3, 2, 1, 3. And then since you see the maximum number is 3 and it repeats itself twice, the number that will be returned is 2. Now let's talk about the code. How do we solve this one? Okay, so this one I will also solve it in Python. So first, again, let's have a list of candles that we can use to imagine what we are dealing with. Let's say you have 4, like they had given us 4, 1, 3, or even let's add an extra 4 here, just so that we know it works. So now what we should return here, as you can see, we have 5 items and then the highest number or the maximum number in all of these numbers is 4, and 4 occurs 3 times. So that means our function should return the number 3. Now, what we need to first do is we need to try to find the tallest candle. So we will be reusing. So now, if you notice, some of the concepts that we are using here, we used them in the last problem of minimax sum. So we'll need to find the tallest. With tallest, we can use the max function. So in order for us to find the tallest, we will try to find the maximum of candles. So that will be max of candles. Yeah, if I spelled it correctly. Yeah, and then now we will try to use a built-in function again, but this time not max. We will use count to count how many times does this tallest candle occur inside candles. So it should be able to return 3. But first, let's print tallest to see what do we get. What we are expecting to get is what we're expecting to get is 1, 2, 3. So we should get 4 because it's the maximum number of all these. So let's try to run our code. We should get 4. So okay, our function right now is returning none. Sorry for that. I'm printing. So let's, instead of printing it, let's return it. Return tallest. Run code. Yes, it is returning 4. 4 is the maximum number in that list. But remember, we're not solving the problem for now. We're just trying to see if our code works. So now, let me do that again. Just comment it out. So now we need to count how many times does that tallest number occur. So count is equal to candles dot count, and then we pass in the number that we want to see how many times does it occur inside candles. So we pass in tallest. So let's try to return this time. Let me uncomment it. This time let's try to return count to see how many times does it return, does it occur, does the tallest candle occur. So we should get 3 this time. So when we run it, run code, we should get 3 as our output, and we do indeed get 3. But now let's solve the final problem. I need to remove my own predefined candles and let them pass with their own code. So run code, it should pass now. It does pass. And when we run it against their test cases, they all pass. So does anyone have any questions regarding this problem? Okay. Yeah, I'm gonna assume again that no one has questions. So thank you guys. Okay, now let me.
Somebody
Oh,
has a question, Musa.
okay.
Please
if
go
you can
ahead.
go up, Abdimajid. Yeah, you can go.
Hey guys, can you guys hear me?
Yes,
We
I
can
can
hear
hear.
you, Ali.
Okay, sure. I don't want to put you on the spot, but how will you solve for it without using the count function?
Without using the count function.
Mhm,
Okay. I would use a for loop to count
mhm.
the occurrence of that item inside the list. So I don't know if like there's enough time. Okay, let me do it. It's not gonna take a lot of time. So I would use a for loop to keep track of how many times does that number occur. so that I make sense, let me comment out this where I don't use the pre-built function. And also with tallest, let me comment it out. And then let me do it somewhere here above. So I will create tallest, and then it will begin with 0. I will initialize it as 0, and then count will also start from 0. And then I will use a for loop like I had said. So for, and then, oh, sorry, for I in range of, so in Python, you will use range, and then you find the length of, when you try to iterate through a list, you use, even if it's not a list, usually you use the range function. So it will be the one that is keeping track of whatever count you want to use. So normally here inside it will be an integer. So maybe let's say in range of 5. And then let's try to print, or rather, let's try to create, I just want us to see how that works. So let's create a collector, a variable called collector. So it will be an empty array. And then we want to add all these numbers inside a collector. So we will say then collector, sorry, collector dot append. So append is basically adding each and every one of those number as the for loop goes by. And by the way, here, by default, the range function has three arguments. The first one is where it will start. By default, it starts from 0. So this is how it will look, 0. And then this is where it will end, but this number is not included. So that means it will end at 4. So it will say 0, 1, 2, 3, 4, and then it will not include 5. And then the third parameter is 1 by default. So if you just include inside these brackets, if you just pass in one number, it will assume that it starts at 0 and then it ends at the number that you just entered, which is 5. And then the count, the last parameter, which is the count, which means it will increase by 1. So when it moves on from 0, it will increase by 1. So it will go to 1. And then from 1, it will increase by 1. It will go to 2, and then 3, and then 4, and then 5. If you add 2, it will, from 0, it will jump immediately to 2, and then it will jump to 4, 6, 8, 10, 12, and so forth, up until the maximum. But if you just pass one number, it will stop at that number. So let's append I in this list, and then, sorry, in this list, and then return that list. So return, the list is called collector. So collector. And then if we call, now let's try, so in when we print out, we should get the numbers 0, 1, 2, 3, a list of numbers 0, 1, 2, 3, all the way up until 5. So let me run that code. So yeah, we get list of 0, 1, 2, 3, all the way to 4, but 5 is not included. Now, why am I saying, why am I showing you this thing? Is so that you can now understand why am I trying to solve the count of those without using the built-in function called count. So this is how I would do it. So I would go back to the for loop, but this time instead of predefining the number as 5, because we don't know how long this list is going to be, we are going to say for I in the range of the length of that list. Now the list that we have is called candles. And then we will say for each and every one of these numbers, if count is greater than, actually no, if the current number I is greater than Okay, so if the number inside count, so it will be like this. If it's greater than the tallest, if it's greater than the value here, 0, then tallest will now become that number. So tallest will become that number, right? And then we increase count by 1. Count by 1. And then otherwise count it's not increased. So I assume this should also work, but at the end we need to return outside the for loop. We need to return count. So we should get 3 also. Let me run it.
Before you run this, apologies for disturbing you.
Mhm.
I see that you are indexing into count. Yeah, okay. Says that in the error.
Yes, there's an error here. Yes, you can continue. You can continue.
Can you guys hear me though? No?
Yes, I can hear you. Can you hear me?
Yeah. I've noticed that you are indexing into count. Just a slight bug that I want to point out. Was that
Okay.
intentional or?
No, that was not intentional, by the way. It's the
Oh.
nerves. But thank you for catching
Nah,
that.
no problem. No problem. I understand. Yeah.
Okay, thank
Yeah.
you. So yeah, as you guys can see, that was supposed to be candles. I was indexing
Mm.
into something that is uniterable. So yes,
Makes sense.
there's that too.
Yeah, no
So
problem.
let's run. Okay, there's another error. Okay.
Yeah, below the if statement. Yeah.
Forgive me, candles. Hopefully it runs this time. Wait. Candles. Tallest count 1. Return. Wait, why am I returning twice? Okay. Return count. Run. I think it's because we need an else here to say else. If it's not greater than tallest, just continue. I hope this works. If anyone can see where I'm going wrong, they can give a suggestion.
And then try to check if it is equal and then you add the number. Let's say the 4 is equal, because I think it check the tallest, but only one that is taller than that number. So it doesn't run the loop through the other 4. So maybe use unless if angle I is equal to tallest, and then you add the count.
Oh, okay. Okay.
I could be wrong also, but I'm thinking should not say run.
If candles I is equal to tallest, then also increase the count by 1. Hopefully this works. Okay, this time it returns 3 instead of 2.
Is it the 3-4 on that candle? Remember the one you created already?
Oh, sorry. So yes, with regards to this to this candles, it should return 3. Forgive me. Hey, okay, forgive me, guys. So now let's see with the ones they have, does it work? So yeah, it works. Let me try to submit it and see what do we get. So some of them they do fail, but this is because of the edge cases. I can't unlock them right now, but it's probably because I'm not taking into account certain edge cases, which will make our code much longer. So for now, we can stick with the pre-built functions using the max, like in the first solution that I offered. But with this one, it does offer you the idea that instead of using the count that we already have with Python, and while we try to find our own tallest here, like we can use a for loop instead of using the ones that are pre-built into Python. So thank you guys for helping me. It goes on to show that sometimes, programming is not only like a one-man thing. You need other people to help you with the concepts, because I'm also learning through as I'm going through the whole thing. Because in Unisa we have been taught in C++, and then I'm trying to learn on my own using Python. So thank you very much, guys, for helping me. So now let me try to move on to the last one, which is time conversion. Okay. So with time conversion, you will be given time in the format of, okay, so I didn't enter it here, but I can go and show it inside the website. So you'll be given time in a 12-hour AM/PM format, and then you need to convert it to military time, which is the 24-hour time format. And then note that 12 AM on the 12 o'clock, on the 12-hour format is written like this. And then on the 24-hour clock, it's just written 12 o'clock PM. And then, sorry, it's written like this in the 24-hour format, but like this on the 12-hour format. And then with PM, 12 PM, it's written like this on the 12-hour format, and then written like this on the 24-hour format. So you'll be given a string like this, and then it needs to return all of this time without the PM or the AM. So as we know, AM is the early hours, PM is the hours after midday. If I remember correctly, AM means ante-meridian, and then PM means post-meridian. So you'll be converting it into 24-hour format, time format, without the AM or the PM. So the only thing that will change will be the hours. You need to add 12 into that. For example, 1 o'clock is 13 o'clock. Sorry, 1 PM is 13 o'clock in the 24-hour format. So the minutes and the seconds will remain the same, but the hours will change. They will be added by 12. So if it's 1, you will add 12 to it, and then it will be now 13 o'clock. If it's 3 in the afternoon, 3 PM, you will add 12 to it. Now it will be 15 o'clock. So that's basically what you're doing. Let's go through the descriptions again. Complete the time conversion function with the following parameters. So they pass in string, which is called S, which is time in 12-hour format. And then what you need to return is a string of 24-hour time format. As they say here, the first two letters of that string will be the hours, and then you will have a colon in between, and then it will be the minutes, then you have a colon in between, and then you have seconds, and then the last it will be the meridian part, which is either AM or PM. So they're saying all input times are valid. So this is the input. It has PM after it. That means we'll be adding 12 into this or onto this 7. So 12 plus 7, that's 19. So you should get this time as it is without the PM at the end. So now moving into the code, let me change the theme to light theme. Moving into the code, we will use slicing. So in Python, we have this thing called slicing, where you can split the string into like its different parts. So how you do that is you index it. So I will show you just now. So we are given string s. We will try to split it. Let's say string s is equal to something like this. The time they given us the 07 07 05 45 p.m. So when you look at this string, think of it like a list with index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should have 9 items inside it. So you know the first 2 items, it will be the hours. The third one is the colon. Fourth and fifth will be the minutes. Sixth will be the colon again. And then 7 and 8 will be the seconds. And then 9 and 10 will be the thing is, it will be the PM or AM. So now we will want to split it. So you only need to, like we said, this part will remain exactly the same. The part we are only changing is the hours, and we are also removing the PM or the AM, and then we're retaining whatever is left. So let's remove this part, the period, the PM. So we will use slicing in period. So in Python, so we'll call this period is equal to s, and then we have something like this in Python, where let me do this. You pass in three things. This is called slicing. So it will, when you do this 1 to 1 to 1, it will return only this one at index 1. So this is where it will start, this is where it will end, and this is how many it will bring, how many characters it will bring. So by default, it starts from 0 and ends at the end of the string. And then the count by default is 1 also. So now what I'm trying to do is I'm trying to get the PM. So with the PM, we can say get the string, slice the 2 last items at the end of the string. So we can use -2 like this. Sorry, it was like this, right? We can use -2. So it will start counting from the last one, but then we need to remove these ones by default because we said it will go to the end. So when it does this, it starts counting from the beginning and it tries to go to the start. But since we said only -2, it will return 2 of the first items. So it will cut out PM. So when we print period, we should get that PM. So print period. Let's run that code. Sorry, I should do this. The way it needs to stop. So by default, we want it to count by 1 and then start from the end of the string. So this is what I should have done. But since by default the count is 1 anyway, let's remove that 1. So run the code. Oh, I'm not returning, sorry. Need to return period. instead of print. Return period. So run code. Let's see my output. Wait. It's not slicing. Return period. Oh, sorry. It should start from -2, not end. So let me do that thing again. Can you guys? Oh, I'm so sorry. Like this, run. So yeah, this is the PM. So it only returns that last part. And then now we get the time part, which is everything else without the PM. So this now it will be the reverse of what I just did. So we start at the beginning by default, and then we ended the last 2 items. So that's what we just did. Now PM. No, we need to return time part this time. Time part. Run code. We should get that time without the PM. So yeah, that's what's happening without the PM. So yeah, now that we have that, we need to write out the functionality that if it's PM, then add 12 into the thing. But if it's AM, just remove the PM. And if it's 12 o'clock AM, you should just convert it to 00. If it's 12 o'clock PM, you should just leave it as PM. So let's show that functionality. Now we are going to split these things again so that we can get only this part. So this time we will use the split function. So here we used the slicing function. Now we use the split function to get the hours only. So hours and then minutes and then seconds is equal to time part. Now we're using this time part because it's returning only the time without the PM or the AM. So time part dot split, but we split using the colon. So let's try to print these hours only. So return hours. So we should only get 07. Yes, we are getting 07. So with this 07, we will say if there's PM here, add 12 to this 07 so that we get 19 o'clock. So let's do that. We'll do that with an if statement.
I'm so sorry to interrupt you, Musa. Thank you so much for the presentation, but I need you to pause here for a moment because we have another volunteer and time is already moving out, and I'm sure people need to run. They have things to do. It's already 6 p.m. and Charmaine hasn't presented. The time is out. Can you guys stay for 5 more minutes so Charmaine can present for us quickly? And thank you so much. And also our guest speaker, Cynthia, we also have to cancel her and postpone for today because she'll be telling us how to get into the industry since she's the tech recruiter and we need to give her more time, at least 30 to 45 minutes. So she will be presenting in our next session. For now, can we just please give Charmaine 5 minutes and we can all leave, please? And I'm so sorry about this, Musa, but time is running out.
Yeah, no, that's cool. That's totally cool. I'm taking too long. I'm also realizing that. Thank you very much. Thank you, guys.
Thank you so much. You rocked. You killed it. We appreciate you very much.
Thank you. Thank you so much.
Charmaine, are you still here? Charmaine? Okay.
Hi, I'm here. Sorry.
Yeah, please. I see people have agreed to give us 5 minutes so that you can take us through your solutions. The stage is yours.
Okay, it's my screen showing. I'm using a phone. Sorry, my laptop got the problem, so I'm gonna use a phone to quickly sum everything up. Do you see my screen?
Yes, we can see your screen.
Okay, so I wrote out the problem statement so that I can be quick and get to the point. So I'm gonna explain, because I already did all the challenges and got the badge for problem solving like long time ago. So I'm just gonna explain how I got to the stages to, so the diagonal differences. So that's what I'm gonna do. So in the diagonal differences, we're given a square matrix to calculate the absolute difference between the sum of its diagonals, right? So the example they've given us in the HackerRank, so I tried to like copy it down in this online Python IDE editor thing. So for example, the square matrix array is shown below. So it's 1, 2, 3, 4, 5, 6, 9, 8, 9. So I'm gonna start by, I want us to understand what is the square matrix, right? So the square matrix means that the same number of rows and columns. So for example, if we have 3 rows, it means we have 3 columns. If we have 5 rows, we have 5 columns. That's the square matrix. So what is the diagonal difference, right? So before I can explain what they want us to do, so I'm going to explain this part. So what is the diagonal difference? Square matrix, I mean, is that we have the primary one. So the primary one it means left to right, and then it starts from the top left and corner and goes to the bottom right, right? So it means that I write this down here. Yeah. Well, here's the things I'm talking about. So I tried to write this as quickly as possible. So it starts from the top left. Start from the top left corner and goes to the bottom right. So, for example, if we have the array 0, 0, array 1, 1, array 2, 2, means that row index equals to column index. That's the pattern. So the pattern is array, the I, and the I. I'm going to explain what the I means in this case. So in the secondary one is right to left. So it starts from the top right and goes to the bottom left. So for example, it's gonna be 3 times 3 matrix. So it's array 0 to 2, 1, 1, and 2 to 0. So the pattern here is I, n minus 1, n minus I, where n is the size of the matrix and I is the current row in index, right? So in this questions, we need to find this. We need to find the sum of the primary diagonals, the sum of the secondary diagonals, and the absolute difference between the two sums. So the absolute difference means that the primary sum minus the secondary sum, right? And the absolute value means if the result is negative, we should make it positive. So in this case, because we are using, I'm going to be using a Python 3. So the reason I'm using Python 3 is because it has clean syntax and is easy to read structure, build, and functions like apps, as I've written here in line 158. And then the other part, so I'm gonna go back to the question so that we can understand what I was explaining. So in this case, the square matrix array is shown below. So here they give us the left to the right diagonals, 1 plus 5 plus 9. So the sum of this left to right diagonal is 15, right? And then the right to left diagonal is 3 plus 5 plus 9, which is 17. So this is the absolute difference. Remember, as I said there, that the absolute difference means that the primary sum minus the secondary sum. So this is the primary sum minus the secondary sum. So in this case, it's 15 minus 17 equals to 2. But then this will be like a negative number, but this is how they showed it. So the function description in this part. So they want us to complete the diagonal difference function with the following parameter. The int is integer, right? So it's int array and int amp, and in the 2D array of integers. So they also want to us to use the return part where the integer is into the absolute difference in sums along the diagonals. So I'm going to quickly write the solution here. So in this case, if we got things like that, as I say that they want us to find the sum of the diagonals, primary diagonals, secondary diagonals, and the differences between the difference between the two sums, which is the absolute, right? So we're going to do the thing. So here we're gonna say define diagonal difference. Sorry with this big spelling. I'm just gonna write. It's not like I'm gonna run this. Define, right? And it's gonna be n equals to length array here. Here, the length array gives us the here the n equals to length array. It gives us the number of rows in this case. And then we have the primary sum equals to 0 plus 0, and we have the second. So we have that. So since it's a square matrix, meaning rows equal columns, and then those two, the primary sum equals to 0 and the secondary sum equals to 0. This is we created a variable to store sums. So we need to separate the two. So the two needs to be separated. So that's the reason why I wrote it like this. Then we're gonna say for so also here we used a list. So this list is called the 2D list. So meaning it's the list inside a list. It's a list inside the list. And also in Python we have indexing. So the Python starts indexing from 0, doesn't start indexing from any number. It starts indexing from 0. The reason why we use that, and we were gonna use the for loop again to move through the rows. So for this part, for I in the range, the one I'm writing now, for in the range
While Charmaine is still typing, I thought I should tell you guys that after Charmaine presents, the meeting will be over. Thank you so much for joining. We really appreciate it. And those who volunteered, Mosa and Charmaine, please make sure you send our secretary, Euseria, your emails so that they can send you guys the certifications of participation just to thank you guys for volunteering. And for those who would like to volunteer to solve more problems in the near future in our meetings, please join the WhatsApp group, and that's when you will understand how you get into the process. Thank you so much.
Mhm. I'll be done now. Primary sum. Okay. So let me explain this again. So I said for the in range, right? So in this case, as you can see that going back, I said, move this so that you can see. Okay, so this is the solution that I wrote in the previous code, right? So the thing is I can't write on the screen, so I can't do so. I'm a person who like writing when explaining something. So here I defined a diagonal difference, right? And then n equals to the length area. So this length area, it gives us the number of the rows. So whenever you are solving this, you have to remember when you're solving with Python, because I tried it with Java, but I couldn't get through because I'm not strong with Java. So I'm not strong with Java. So I just stick with Python in this case. So, and as I was explaining that the reason why I also used Python is because of the list part. So we have something called the 2D list. As is mentioned in the problem that this is a 2D array problem thing. So I use the 2D list, so meaning the list inside a list. So in this case, in the in this part for in I range part in line 167, if you guys see there. So the range into n generates a number from 0 to n minus 1. And minus 1. So this becomes the index. So for example, if if n is equals to 3, meaning I will equals to 0, I will equals to 1, and I will be equal to 2. So for if n equals to 3, so it's gonna be 3 minus 1, so it's gonna be 2. N minus 1 is going to be 1. If 2 minus 1 is going to be 1, and then 1 minus 1 is going to be 0. That's the reason. So in this F for in range to understand. And then when we are summing the diagonals, right? So inside the loop, we have the primary sum, meaning from left to right, and then the secondary sum is right to left, right? We said this one is start from the top top right is it top right to the bottom left, bottom right, and then the other one from left to the top left to the bottom right. Yeah, so it's a vice versa kind of situation. So in and then the absolute value here. So because Python has an inbuilt function, the apps part, so the let me just write it in the bottom of this, doesn't matter. So in here, the apps, sorry about that. Apps is gonna be the number, right? Going back to the question that we were asked, we were told that the the sum of the first part, it was 15, 15, and the sum of the second part was 17, right? So this creates the sum, meaning that 15 minus 17, which will give us 2. So that's how the absolute works in this case. And also there's something that I called the time complexity. So I'm just gonna write it here. So in the time complexity part, time complexity in this case, right? We have right. So in the time complexity part here, this explains that we loop once through the matrix. So here it shows that we loop once in the matrix. And then we have another one called the space complexity. Okay, this one is. So the time complexity, we only use the extra variables. So this one is for the diagonal part, the diagonal differences. So anyone has a question or lost or anything? Okay. We'll move. Is everyone fine? Am I audible?
Yes, I can
Yes, you
hear
are audible from my side.
Are you guys fine? Okay. Let's move to the staircase. Anyone with a question, or should I move on? Okay, let's move. So I'm gonna go down there. Okay, now let's solve the staircase part. So for the staircase part, I wasn't prepared, so they told me this morning, but I do have the question written on paper. So in this case, they will check it out. Sorry for that. For the staircase part, I wasn't prepared at all, but I did solve the question, so I still remember and I know how to explain it to someone else. So the given in the staircase part, they're given a number n to print a suitcase of height n using the hash symbol. So the staircase part, they want us to use the hash symbol to print a staircase height. So they want us to use the hash symbol to print the height. So in this case, the staircase is a right aligned. It's right aligned. So it has n is right aligned. I'll just write these points down. It's right aligned. Right aligned and has n rows. And then it uses spaces, space and yes, okay, yes, it uses space and hashes. So let's read the solution on this side. So, for example, here in the question they've given us, they said if n equals to 4, if n is equals to 4, right, meaning that the hatches will start like this, go down, this, 3, and 4. Yes, that's 4. So that's it. So there's something you have to notice in this. Notice that in the first row, that there's 3 spaces here, just that I can point. There's 3 spaces before the hash. There's 3 spaces and 1 hash. The second row, there's 2 spaces, 1 hash. There is 1 space. It's supposed to be 1 space before hash and then 4. So in that, in the HackerRank, they show it properly. So you will see that, you will notice that there is spaces before the hashes, and that you should notice that, you should like note it down before. So this teaches us that the loops now, for the off loops and nested, so in this case we're gonna use the for loops, the nested loops, the pattern printing, the logic building, and how spaces symbols can be controlled. In this case, this teaches us that the staircase challenge teaches us that. So I used the language C# in this one.
Uh,
Can you?
Hi, Shamin. I'm sorry to interrupt. Thank you very much for the presentation and
I can't hear you
presentation.
properly.
I think it's very valuable to our team. Can you hear me? Hello?
I can't hear you. Can you hear me?
Yes, yes,
Can you
can you
please
hear me?
type? Yeah, I can hear you now.
Okay, thank you. Thank you very much for your time. Am I still clear?
Yeah, I can hear you now.
Yes, thank you. Sorry to interrupt you. I think we need to end the session. Hopefully we'll give you a longer time this time, because I think members, they need to go right now. Thank you for your time. And then also, are you sharing the screen? Maybe we may stop. Just wanna.
Yeah, I stopped.
Okay.
Thank you very much.
Okay.
Even though I didn't have more
Thank you.
time to
Yes,
to present.
sorry about that. Yes, sorry about that. Hopefully next time we'll do. We start with you. It will be much more better. Okay, this is the token of appreciation. Our secretary is going to email to you and Musa. Thank you very much, guys, for your time, and then for helping us understand this problem solving. And for everyone that attended the session, thank you, guys. We update you with the next session and not to with next. This is the end of today's session, and then hopefully we'll get more session. Thank you very much, guys, and bye, everyone.
Bye.
Bye.